multivariable in the sense that we are saying we are introducing a covariates into the analysis. So long we have been talking about age and cholesterol. We never brought any other covariates into the analysis. Now, so therefore it is interesting because we are talking about cholesterol. If someone is a heavy person, his cholesterol is very high. So the BMI plays a role in that analysis or not. If you include that kind of variables, then what happens in the doctor level and institution level and etc. So this is what the BMI plays a role in this relationship. Then the correction has to be made for. That is basically we are saying adjustment has to be done for BMI. BMI plays a very big role for cholesterol. So let us look at this analysis. We are not going to see that Melvin outputs. So this is 399. The same looks like the log likelihood is 399. It's same. And this is the ICCs. This can be calculated 1.2 upon the total. That is nearly 60% or whatever. And this is the standard error seems to be increased by adding a BMI. Where do we add the BMI into the analysis? This is just the age and MD, doctor level adjustment. Where is the model? Did we include? No. So this is just the age centered. Many times when you run analysis, the convergence doesn't take place. What does convergence means? You don't get the estimates from the analysis. Therefore, please remember in any analysis, not necessarily this, if you do regression or logistic regression, if you center the data, what is centering the data? Calculate the mean and subtract the mean from each and every observation. That is called age-centered or BMI-centered. If you input that centered values, a convergence will take place much easily. That is a concept, any regression analysis. And the interpretation is also very easy. From the mean level, if I increase my level to 1 unit more, what happens in the rest? So for two purposes, we use centered values. Now, what is this one? This is random intercept and random slope model. Okay. And here I have used BMI centered in the model. Okay. The covariate BMI has been added. Now let us look at the log likelihood. Log likelihood is 384, not 399. So someone has to help me in understanding this effect. What is it? It has reduced. Therefore, BMI played a very big role than the doctors. So the reduction or whatever the correlation is because of BMI, not because of the doctors. So therefore, it is important that you land up with finally that multivariable analysis when you do the model. Or start off with the multivariable and change your random intercept, random slope and see conclude. Then you will be all right. Do you understand this? So the relationship, we looked at only age and cholesterol, but we did not bring in BMI. Suppose if he has a hypertension or whatever, the role is different, comorbidities, and so on. So the regression model is important. So set the regression model, allow the random intercept, allow the random slope, and take a decision. That may be the right way of going ahead with the analysis. This is very important that covariates altered the relationship, reduced your log likelihood. Therefore, it may mean that it is not the doctor, it is, we said it is not doctors, it is an institution. And because they are equal in effect, we said let us settle with the doctors. Now the analysis says it is BMI, not the doctors. You need to look at the difference between all over again, all the analysis all over again with the BMI in the model and do the analysis. So this is very important. The variance of random intercept decreased from 0.36 to 2.6. So let us look at this. The variance of the slope decreased from 2.7 to this. let's say the variance, it's easy to capture this as the variance of the random intercept. It's 0.36. Here it is not exactly same. The variance of the random decreased to 0.17. This is a random intercept 0.17 in our analysis, our software. We'll have to see what is. .17 for the random intercept reduced to this thing. What is we need to look at what is the value for random intercept. This 0.15. Where is that 101? Standard. Let me show it to you through this example. This is here the random intercept model with the J doctor's level and random slope model. Do you understand this one? J is attached to intercept as well as the slope. The random intercept variance is 0.36. So when you put this model, adding that BMI, it has come down to 0.26. So there is a reduction in the standard error. There is an impact in the model. So therefore, we wanted to have BMI in the analysis. So let us say when you have this kind of covariates which are related to age or cholesterol or whatever dependent variable, it is better you start off with the regression model, full regression model, and allow the random intercept and random slope to change. So then we will not make any mistakes in the final conclusion. That is a message that we wanted to convey to you. So this is huge reduction in the variance of the intercept. Implies that the difference in the medical doctors was due to different ages of medical doctors. This is what another one which we wanted to tell you about. See here, this is age of the doctors. I told you that the only analysis in statistics which allows you to bring in different level covariates. I told you the age of the doctors, experience of the doctors can be modeled into the analysis, lower level. The lower level age and cholesterol was modeled. Age is a covariate and BMI is a covariate. Along with that, we introduced age of the doctors into the model. Similarly, if you have covariates of the institution level, you can also put it in the model. So no other analysis can do that because it captures the correlation structure in the analysis. That is the advantage of doing this analysis. And always the age is centered as useful. When you have a complicated structure, it converges that easily. If it doesn't converge, you remove that variable. You cannot study. Many times it happens when you run a logistic regression analysis for various reasons that some variable will be creating a problem. Just remove them and do the analysis. So, any questions?